Alright, good day viewers. Once again, you're welcome to our online teaching series. Today we're going to take a look at a very simple problem in physics that three coplanar forces F1, 2, and 3 act on a body at point O as shown in the diagram below. Calculate the value of F3. Now you can see the diagram. These three forces F1, 12 Newton, F2, 8 Newton, and another force F3 of unknown value. So we are told in the question to calculate the value of F3. How do we solve this problem? Now let's go together as we solve this problem. Now in solving this problem, let's first of all bring out the diagram again. Now the diagram says that we have three coplanar forces. Now let's say these are the three coplanar forces, and we have a third. Now this is a third coplanar force. Here we have our F3. We have here our F1 and here is F2. Remember, it is a vector force. They are all forces, vectors. Now the angle between them, F1 and F2, is 60 degrees. Now to solve this problem, first and foremost, I would like us to understand that F3 is an equilibrant force. Equilibrant forces are single forces that counterbalances the effect of two or more other forces acting on the body. Now here, the equilibrium force is always H, opposite and equal to the resultant force. Now in solving for the value of F3, we are first going to take a look at here. Let's use the law of parallelogram, law of vectors. Using the parallelogram law of vector, I am going to draw a line that will be parallel to this line. Now I draw something like this. And yet, here at this point, I draw another line that will be parallel to this. Now, if I do this, you see we have a parallelogram. Now, if I cut the resultant of this parallelogram, cut a line that cut from the diagonal of the two vectors, and I have here as my arrow the resultant vector. Now remember, 60 degrees here, the angle between them is 60 degrees, and is divided into two equal parts. It means that this angle at this point will be 30 degrees, and this point will have 30 degrees. So automatically the same thing is applicable here. So this angle here will be 30 degrees, and this also angle here 30 degrees. Now I would also like us to understand that if here is 30 and this is 30, that is 60. The total angle in the triangle is 180, so here automatically is 120 degrees. So we should understand F1, now F1 is equal to here, let's say here we have F4. F1 is equal to F4, while F2 will be equal to F5. Now let's resolve. We are looking for the resultant. To get the resultant, let's use the cosine rule. Now using the cosine rule, if we use the cosine rule, we have that our resultant r squared will be equal to F1 squared plus F2 squared, then we have minus 2 times F1 times F2 times the angle between them, which is cos 120 degrees. So we have our r squared here as equal to F1 is 12 squared plus 8 squared minus 2 times 12 times 8 times cos 120 degrees. Our resultant r squared will be equal to 144 for 12 squared plus 8 squared is 64 minus 2 times this will give us 24. 24 times 8 times cos 120 degrees. So we found out that 64 plus 144, that is supposed to give us 208. So r squared now will be equal to 208 minus 24 times 8 is supposed to be 192, I think so. 24 times 8, that is supposed to give us 192. 192 times cos 120 degrees is the negative version of cos 60 degrees. So what we have here now is cos 120 degree will give us minus 0.5. So automatically what we have here is our arrow squared now will be equal to 208 plus, because negative minus 192 times 0.5. So half of 192 times 0.5, that will give us 96. So we'll have it plus 96. So our arrow squared will be equal to 96 plus 208. That will give us 304. 304. But what we are looking for here now is the resultant. So therefore, the resultant R is equal to square root of 304. So square root of 304, that will give us 17.4, and that's equal to 17.4 Newton. So therefore, the resultant is equal to 17.4 Newton. But understand that this force you have here is the equilibrium force. And I said the equilibrium force is directly opposite the resultant force. So therefore, F3, which is equal to the equilibrium force, the equilibrium force will be equal to 17.4 Newton. But remember, it is the opposite, direct opposite of the resultant. So we have the value is 17.4. But since it is the direct opposite of the resultant, we can put, just say, the minus sign. But we should understand that the value we have there is 17.4 Newton. So therefore, F3 is equal to 17.4 Newton in the negative direction, opposite to the resultant. That is the value of our F3. Thank you very much. I believe what we have on the board explains the problem we have here. Please take advantage of what you have seen, read more, and I believe you get to the scope of this topic. Thank you very much. If you have any question, just drop it on the comment section. I will get back to you. Bye for now.